Dear students, I am Dr. N. Kavita and you're watching LPV Chemistry Learn, Practice and Victory. Students, in this session, we are going to learn how to prepare caustic soda. You know, the caustic soda is used in detergents and it has many purposes. Caustic soda is prepared in industrial process by using chlor-alkali method. Caustic soda is prepared by electrolysis of brine. So let's get into the session to know more about it. Thank you, students. How to prepare caustic soda using electrolysis method. Students, you know what is electrolysis? Electrolysis is a method in which direct current is passed through the solution. What is the solution taken here is common salt, otherwise known as sodium chloride. So here the electrolysis of brine is done. Brine is known as sodium chloride. So the question can be, what happens on electrolysis of brine? So brine is nothing but your sodium chloride common salt. And the question can be, how can you prepare caustic soda or NaOH? So if you get a question caustic soda or NaOH, you have to understand that it is all the same question. The question can be direct like chlor-alkali process. Explain chlor-alkali process. So the questions can be any type, but here the answer is going to be the same. Electrolysis of brine, prepare caustic soda, explain chlor-alkali process. Students, here you have given a compartment. This compartment is provided with a inlet and a outlet. In the inlet, brine is taken, nothing but your sodium chloride with water. There are two electrodes attached to the compartment. One is the anode, which is positive, cathode, the negative. Cathode has ability to attract the positively charged ions and anode has a ability to attract the negatively charged ions. As you know, the reaction is sodium chloride when it treated with water and direct current is passed through, it becomes NaOH, Cl2 which is your chlorine gas, H2 which is your hydrogen gas. Here you can see that there is a membrane which is in the partition of both compartments. This is a semi-permeable membrane or it is a ion exchange membrane. This membrane is used so that the ions such as Na plus, H plus, when it flows from one compartment to the other compartment, it does not revert back. So the purpose of the membrane is to allow only the positively charged ions like Na plus and H plus through with along with water through the permeable membrane, and it prevents the back diffusion of the same. Students, this semi-permeable membrane example that is used in industrial purpose is Nafier, which is a semi-permeable membrane. It is made up of perfluorinated sulfonic acid polymer, is an ion exchange membrane. Here, as you can see that the Na plus moves towards the cathode and chloride ion, OH minus ion, hydroxide ion moves towards the anode. What happens if this physical barrier is not there? The membrane is a physical barrier reducing the diffusion and prevent the mixing of the product. So Because of the semi-permeable membrane, the diffusion and mixing does not take place. Here you have Na plus, H plus, and here you have your OH minus, Cl minus. Because of the membrane, it does not diffuse back. This is your cathode and this is your anode. At anode, what happens, and at cathode, what happens, we will see. Initially, the Cl, which is formed at this compartment, the chlorine is formed at this compartment, which is close to the inlet. So the chlorine here in the aqueous solution, it gives Cl2, which is your gas, with release of 2 electron. Now this chlorine is covalently bond. As you know, it is Cl and this is a covalent bond by sharing. Here, because it gives away 2 electron, the loss of 2 electron makes it the process as oxidation. And at cathode, you can see reduction. Here at anode, it is oxidation. In cathode, you have hydrogen, this H plus proton, it gains electron, 2 electron, to give H2, which is your hydrogen gas, and the remaining Na plus and OH minus in the brine solution along with Na plus Cl minus, it will give you the caustic soda, which is NaOH. So here you have your brine containing NaOH. This is about 32 to 33%. The brine contains NaOH. The H2 is released at cathode. Chlorine is released at anode. The remaining Na plus and OH minus in the brine is separated from the outlet, and this brine contains 32% of NaOH, which on concentration and purification gives 50% of caustic soda. Students, you can understand that you have now chlorine gas, hydrogen gas, and NaOH. NaOH is used for making detergents. H2, which is your hydrogen gas, and chlorine gas that are used as fuels. Now, the chlor-alkali method, you have prepared not only the NaOH, which is your caustic soda, also chlorine gas and hydrogen gas from the brine solution. I hope students you have understood this topic well. See you in the other session. I request you all to subscribe, share and like my videos. Thank you, students.